Everyone, I welcome you all in this second video lecture of A-level physics, and we are doing chapter 2, kinematics, and the highlight for today's lecture is point number 6. We have to derive from the definition of velocity and acceleration the equations that represent uniformly accelerated motion, and then of course we have to solve problem using equations that represent uniformly accelerated motion in the straight line, including the motion of bodies falling in uniform gravitational field without air resistance. So today we are going to cover these two syllabus points. Well, so far, the calculations that we are done in kinematics are the speed, which is distance over time, velocity, which is displacement over time, and well, you can use only these formulas if speed or velocity is constant or acceleration is zero. Average speed is total distance over time. Average velocity is having two formulas. One is displacement over time, and if the object is moving with constant acceleration, average velocity can be determined by adding initial and final velocities and dividing it with 2. Then acceleration, change in velocity over time, v minus u over t, is positive. So positive acceleration. If the answer comes out to be negative, it is called deceleration. From the graphs, we have determined so far that from the distance time graph, the slope or the gradient gives you speed or velocity, and area under graph gives you nothing. For the velocity time graph, the slope gives you acceleration and the area under graph gives you distance or displacement. For acceleration time graph, the slope gives you nothing, but the area under the graph gives you change in velocity. The number 7 is the set of equations that we have to study today. These are commonly called Suvat equations. Why they call Suvat? Because they contain 5 quantities: S, U, V, A, and T. S is displacement, U is initial velocity, V is final velocity, A is acceleration, and T is time. Or these are commonly known as equations of motion. So these are actually 5 sets of equation of motion that we're going to use only if the acceleration is constant. So this is the condition to use these equations. As I told you earlier, the 5 sets of equation, which is having relation with displacement, initial velocity, final velocity, acceleration, and time, and we can use these equations to find any of these quantities from S, U, V, A, and T, and only when acceleration is constant. So here is the list of 5 Suvat equations. So the first one is V is U plus AT. Second one is S is UT plus half AT square. Third is 2AS V square minus U square. Fourth is S equal VT minus 1/2 of AT square. And the last one is from average velocity. It is S equal U plus V over 2 into T. So a thing to note in these is that there are 4 quantities in each of this equation. There are 4 quantities. If you look here, it is V, U, A, T. So 4 quantities. If you look here, S, V, T, and A. So 4 quantities are there. If a quantity is repeated, you will count it once. The next noticeable thing is one quantity is missing in all of these. Like in equation 1, S is missing. In equation 2, V or the final velocity is missing. In equation 3, time is missing. In equation 4, initial velocity is missing. And in equation 5, acceleration is missing. So these are called missing quantities. And these are very, very important because they will help you to decide which equation you're going to use in a particular question. Now, the most important thing, the derivation of these Suvat equations. This is very, very important. So the first one is relatively simpler one, which is V equal U plus AT. So you know the equation of acceleration, that is V minus U over T. So you just rearrange it for v. So you shift t to the other side, at is v minus u, and you shift u to the other side, so u plus at is equal to v. So that's how you can get your first Stewart equation, which is actually the equation of acceleration. So you just have arranged it. Okay, let's look upon the second equation now. The second equation is s equal ut plus half at square. You must have used that in your IGCSE exam as well. Nowadays, as the Cambridge is bridging up the gap between IGCSE and A level, so they are using these equation in IGCSE as well. So let me put you in a situation. This is an object with initial speed u, and it has constant acceleration, and after time t it covers s displacement and its final velocity become v. We can picturize this in the velocity time graph as well. Let's say it is starting from here, not starting from 0. Why? Because when we started recording its motion, it was already having some initial velocity, and as the gradient, you can see the gradient is constant, so its acceleration is constant, which is one of the condition to use the equation of motion. So the final velocity is v after time t. It's still same thing. So the displacement as moved by the object can be determined from area under the graph. So this area under the graph, this whole area under the graph can give you the displacement or the distance moved by the object. So let's find the area. So this is the first parallel side P1, and this is the second parallel side P2, and this is the height between them. So area is 1 by 2 sum of parallel side, which is u plus v, because this parallel side is u and the other parallel side is v, right? And multiplied by height is t. So you just multiplied them, and area is s, so 1 by 2 u plus v into t. Now what you have to do is you have to use first equation of motion, which is v is u plus at, and what you're going to do is you have to replace the value of v over there. Why you have to replace the value of v? Because if you look in this equation, v is missing. V is not part of this equation. So this will help you in deciding that, okay, you have to remove v from this expression because v is there. So what you have to do is you have to remove v. And how you can remove v? You take help from the first equation, v is u plus at, and you just plug in the value of v over there. So you can see that I have plugged in the value of v over there, which is u plus at, and then of course you have to simplify them. U and u makes 2u, and then you multiply 2u and at with this t, so 2ut half and sorry, at square, and then you multiply this half with both of them, and eventually you got this answer, which is s equal ut plus half at square. Jumping to the third equation, which is also very important, you can see that time is missing in it. Time is not there. So what you do is you have to consider the same situation and the graph as in case 2. Same situation, this one. This is the situation. So you have to consider the same situation over here. So object is moving with u after some time t, is covered displacement s, and its final velocity is v, and you have to look for the same graph. So same graph, so we will be using it in over here. So the graph equation was this. The area under graph is s is half u plus v into t. So now again you're using first equation, but this time you need to replace t. Why? Because in this equation t is not there, t is missing. So from the first equation you are making t as the subject. So t is v minus u over a. So you just plug in the value of t over there. And then of course you simplify it to get the value of 2as equal v square minus u square. Okay, the equation number 4, which is s equal u plus v over 2 into t. This is one of the simpler equations. Again, if we consider the same thing, that the object is moving with initial velocity u at time 0. After time t, it uniformly accelerated and it gains the velocity of v. So we know that area under the graph is displacement. So area is half u plus v into t. So S is u plus v over 2 into t. So that is actually over fourth equation of motion. So we don't have to do anything else. Number five. Number five is S equal vt minus half at squared. This is vt. This is slightly different than equation number 2. So you can see equation number 2 is S is ut plus half at square. And equation number 5 is S is Vt minus half at square. So again, you have to use the same graph and its equation as you have used in equation 2, 3, and 4. So the area under the graph is half u plus v into t. So you replace now, because in this equation, you can see that u is missing. I hope you have now got the trend that you have to see that which equation is missing, which quantity is missing from the equation, and then you will replace that taking the help from first equation of motion. Like first equation of motion is very important. It is helping you throughout the derivation of these equations. So from this, what you're going to do is you're going to make u as the subject. So u is v minus at. So you replace this u's value as above over here, and then you can just simplify it to get s is vt minus half at square. It is advised that you can just pause the video and you can have a look at that and try to derive these equations yourself as well. In case if you come up with any ambiguity, then you can contact me in the comments box. Okay, so an important thing related to these equations, these derivations may come in the exam, and these will build your derivation skills which are required in physics A levels. Okay, let's jump to exam style questions related to equations of motion. So there are three type of questions. The one is the simpler ones, one situation based question. Second one is complex situation based questions, like two or more situation will be there. And the third one is the paired with the graph based questions, like the graph based questions will be there as well. So let's look upon the method to solve questions related to Suvat equations. So the method is common, whether whatever type of question you're doing from 1, 2, and 3, you will adopt the same method. So first you have to pick up data from the given statement, diagram, or the graph. Second, you at least three quantities out of five, like S, U, V, A, T, must be known. So you should be very careful. This is one of the most important thing, that three quantities out of five must be known. Sometimes they say object starts from rest, so it means u is 0. They will not tell you that u is 0, but you have to figure out yourself. Sometimes they say object reaches maximum height during its vertical motion. So you see that at maximum height, the final velocity is 0. You have to figure this out yourself. So sometimes you have to figure out the quantities yourself, that what is the quantity. And sometimes they say the object is in free fall, there is no air resistance, and you dropped an object downward or you throw an object vertically upward. So that indicates, like if they say there is no air or negligible air, that indicates that acceleration is g, which is 9.81. So you have to figure out some of the quantities yourself. Point number 3, decide the equation to be used from the data and the quantity to find. So you'll take help from two, that okay, these quantities are given and I have to find this, and this quantity is missing. So you will decide that which of the five equations will help you in finding the unknown quantity. S, V, and A are vectors, so be careful with their signs, like displacement, velocity, and acceleration. And we have already discussed on that, and we will throw some more light on their sign convention as well. Before we go to that, we have to look for the vertical motion, which is the free fall motion, that how we can modify the equations. So the first equation is modified, like v is u plus at, but a is replaced with plus minus g, because in vertical motion the acceleration is gravitational acceleration. So instead of writing a, you will be writing plus minus g. Now why plus minus g? Because we know that when you throw something upward, its acceleration is negative. But if you drop something downwards, its acceleration is positive. That's why I assigned positive negative sign over there. Okay, so the second equation is h equal ut plus minus half gt square. So s is replaced with h because in vertical motion we are looking at height. It can be used as s, but h is more appropriate. And acceleration is replaced with plus minus g. Third equation, it is plus minus g 2gh. So you replace s with h and a with plus minus g. Fourth equation, s is vt minus half at square, but over here what we have done is we have replaced s with h and a with plus minus g, and the last equation, s is u plus v over 2 into t, so we just replace s with h. So I mean, for vertical motion you have some other you have to change something. Okay, so I was talking about the sign convention. So if you look upon for first displacement, so like if the ground is there and you throw something upward, it's going upward, 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 and then it's coming downward, 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 and it lands on the ground. So throughout this motion, displacement will be positive. Why? Because the object has not crossed its start line. But if you are throwing something upward from the top of the building, it is going upward, so its displacement is positive. Going downward, displacement is still positive. But once it crosses its start line and go to the other side, so then its displacement will be negative. So to one side of the motion, displacement is always positive, and to other side of the displacement, start point, the displacement is always negative. About velocity, it's simple. Along original direction, velocity is positive, and opposite to the original direction, velocity is taken as negative. For acceleration, if the start point is upward, like you're throwing something upward, so g will be negative throughout the motion. Let's say if you're throwing something upward, it is going upward, staying at the highest point momentarily, then coming back towards the ground. So at all the points, acceleration will be negative. It will never be positive. So its acceleration is, even it is coming down, but you have to look for the start point. The start point was upward, that's why throughout the motion, even at highest point where it momentarily stops, its acceleration is minus 9.81. So if start point is downward, if you're dropping something, then g is positive at all the points. Okay, let's look upon the examples now. So we have to look for all the examples. So first example is the simple case, which is using only one equation of motion to get the answer. So this is a question from October, November 2017, paper 11, and this is question number 18. A stone is projected vertically upwards from the ground at an initial speed of 15 meter per second. Air resistance is negligible. What is the maximum height reached by the stone? So you can see that you have to pick the data. So the first data that you will pick is the velocity, initial velocity, which is 15, which is given over there. Then g is minus 9.81. How you know g is minus 9.81? One, the air resistance is negligible, and second, it is projected upward. So these two things help you that g is minus 9.81. And then this maximum height helps you to identify that v is 0, because I told you that you need to have at least three quantities. So this is first quantity, this is second, and this is third. And what you have to find is, you have to find the height. And what is the missing quantity over there? Which quantity is missing? So you will see that time is missing. Okay. So what you do is, you will look for the equation in which time is not there. So that equation is 2as is v square minus u square. Now you simply plug in all the data into it. So simply plug in the data over here, g over here, and v over here, and you will get the height. So from here, the height comes out to be 11.46. So B is your option in this case. Okay, let's move to another question. Slightly trickier. A hot air balloon is moving vertically upward. So vertically upward is important. Let me just make it a bit smaller. Okay, it's vertically upward with a constant speed of 3 meter per second. It means that hot air balloon is going upward with 3 meter per second. Okay, a sandbag is dropped. This is the sandbag is dropped from the balloon. It takes 5 seconds for the sandbag to fall to the ground. So it takes 5 seconds to reach over there. Okay. What was the height of the balloon when the sandbag was released? So it means that you have to find this height. Now you have to look for the data. So if you look at the data, the initial speed is given, which is 3.0 meter per second. And then the time is given, which is 5.00 second. And then the acceleration will be plus g, which is 9.81 meter per second square. Okay, so next thing is you have three things and you have to find the height. So you have to look for the missing quantity. What is the missing quantity here? So the missing quantity is v. The final velocity is not given. So based on this data and missing quantity, you will decide equation. Decide an equation of motion. So now, which equation you will decide? Tell me. Yeah, that's fine. I can't hear you, but yeah, I can read your mind. You're thinking in the correct way. So you are going to use S equal UT plus 1/2 AT squared because it doesn't have any of the V. Okay, so what you do is you just put the values. H you have to find. One thing that is very important, this velocity is taken as negative. Why? This is important thing because the sandbag will have an initial velocity upward -3. Why -3? Because the displacement is downward, it has to come down, but the velocity is upward. So if the velocity, initial velocity is upwards, you have to take velocity as negative. This is one of the important things. If the hot air balloon was not moving, it was at rest, and you drop the sandbag, then the initial velocity of the sandbag was 0. But over here, as it is moving upwards and displacement is downward, that's why you have to take this as negative, -3. Okay, I hope this is clear. So this was the main thing in this. Plus half, and g is 9.81, and then t is this. So you will simplify this to get your answer. So this will be like minus, this will be -15 plus, this should be around 124 point something. And what you do is, I'm not having the calculator, so I'm just doing it. Oh yeah, it helps me around 109, around, because I'm not using the calculator, so it is option B, right? So the pick of the point was s, the initial velocity, it is negative. Why? Because it was opposite to displacement, because the displacement is downward, it is going downward. If the displacement is downward, you have to take the velocity as negative. Let's jump to the complex cases now. So complex cases means that you have to apply one equation twice or using two different equations. So be careful with one thing in such type of questions, at least one quantity out of displacement, initial velocity, final velocity, acceleration and time remain the same in both situations. Usually it is acceleration and initial velocity that you keep the same. Okay, let's look for the question now. So this is, remember, this is complex, so you have to use one equation twice because two situations will be there. A car moves with uniform acceleration along a straight road. Oil leaks from the car at the rate of one drop every 2 seconds. Like this is drop one, and after 2 seconds, this drop is this is there, this oil drop, and after 2 seconds, this oil drop. The diagram shows the distances between three successive drops. So this distance is 9 and this is 12. So as the distance is increasing, it means the car is accelerating. What is the acceleration of the car? Okay, so what we do is, what data is given to us? So the first displacement is given as 9 meter. The second displacement is given as 12. But we will not take 12, but we will add 9 and 12 together. Why? Let me tell you about that. Look, there is no velocity given, neither initial nor final. So what we do is when the object was over here, we say that let's say its initial velocity is u. You have to assume that its initial velocity is u. This is assumption. Why? Because we are not given with any of the velocity, initial or final. Okay, so then we say that our first patch is this one, and our second patch is starting from this till the end. Why? Because I want to keep some quantities same in both these situations. And if I keep the start point same, then my initial velocity will be same for both of them. So that's why I took this displacement as 9 plus 12, which is the second one. Okay. Now you have time. So if we look upon time, so the first time is 2 second because the first drop is like took 2 second, and the second situation time is 2 plus 2, it is 4 second, right? It is 4. Why? Because you're taking the whole situation. Okay, if you understood this, then we can do this question easily. So right now we have initial velocity, we have displacement, we have time, but of course we have two scenarios for each of them. And initial velocity is the only one which is same in both scenarios. This is same. Displacement in both scenario is different. Time in both scenario is different. Okay, and we have to find acceleration which is same in both scenarios. And what quantity is missing over there? We can see clearly that v is missing. The final velocity is not there. Okay, so what we do is we look for the equation in which v is not there. So of course, it will be s equal ut plus 1 half of at square. Now what you do is apply this in both the situations. In situation 1, you apply in situation 1, and you apply it in situation 2. Remember, situation 1 is when the displacement is 9, and situation 2 is when the displacement is 21. Okay, so let's jump in to apply these equations. So in situation 1, s is how much? 9. U is how much? U. T is how much? 2. Acceleration we have to find, so make it prominent. Okay, and then t is 2 and it's square, of course. So you simplify it, it is 2u plus 2a. So that's how you get this equation. Now applying it in the second situation, the displacement is this 21. So this is 21. This is important. Why I took 21? Why not 19? This is again important. I already told you, and I'm going to tell you again, because the problem is that the object velocity is not given. If it reaches here, let's say its initial velocity is u. When it reaches here, of course, it is accelerating. I don't know that what its velocity will be here. I don't know about that. What its final velocity will be, I don't know about that. So what I do is I say, okay, this is the first situation, and the second situation, I can take the same velocity as u. So in both the situations, the initial velocity can be same. That's why I took the second situation distance as 21. So 21 equals u into 4, because time is 4 seconds now, plus half a and 4 square. So simplify it. So it will be 4u plus 8a. What you do is you simultaneously solve them. Simultaneously solve. This is just one question, but it is taking too much time. Why? Because it is a complex scenario. So when you solve it simultaneously, you say, okay, it is 2u plus 2a. And this one is 21 equal 4u plus 8a. As you want a, So of course you need to get rid of this u. So how you can get rid of this u? You can simply multiply this equation with 2. So multiplying this equation with 2, this will be 18, this will be 4, and this will be 4 as well. So I just multiply this equation with 2, and then I subtract it. Subtracting. So when you subtract it, this is gone, and this is minus 3, and this is minus 4. Minus minus gone, and you can say A is 3 over 4, which is 0.75 meter per second square, and this will be your answer. It took us so long to get to this answer, but yes, that's why it is called a complex case. That's why it is a complex case, because you have to do a lot of work. Let's jump in here. You can always stop the video and try it yourself, and then you can start the video to see that whether you have done this correctly or not. Let me take you to this question. This question is repeated in the 3 years time. It is written over there: 2016, 2010, and 2010. Okay, in order for the train to stop safely, it always passes a signal showing a yellow light before it reaches a signal that's showing a red light. This is related to the train system. Drivers apply the brake at the yellow light, and this result in a uniform deceleration to stop exactly at the red light. The distance between the red light and the yellow light is x. Okay, let me just try to make this over here. So let's say here is a signal, and here is another signal. These are the signals, and let's say the train is over here. I'm just making this as the train. Okay, so they are saying that this one is yellow. Okay, this one is yellow, and this one is red. So what they're saying is that drivers apply the brakes at yellow. So when the train will reach at the yellow, they apply the brake, right? Applies brakes. And this result in uniform deceleration. A is negative constant. And the train exactly stopped at the red. Here its final velocity is 0, right? The distance between red and yellow is x. So the distance between them is x. This is the distance between them. If the speed of the train is increased, now they're putting you in a second. This was your first situation. This is your first situation, right? Now they're putting you in a second situation, because the complex question always involves two situations. Now the second situation is this one. If the speed of the train is increased by 20%. So let's say, let me redraw this again over here. I can just copy and paste it here. So now what they're saying is that the speed is increased here. Here the speed was u, and the final was 0, but here the speed is increased by 20%. So the speed is increased by 20%, so we say it is 1.2 u. Why? Because if this u is 100% and you increased this speed with 20%, so 100 plus 20%, the new speed is 120%. And 120 over 100, it will be 1.2 u. So that's why I have written over there the new speed as 1.2 u, which is 20% more than on day one, without changing the deceleration. It means that this deceleration, like the driver applies the same brake, so these two things are exactly the same. These two things are exactly the same because driver applies the same brakes. What must be the minimum distance between the lights? What must be minimum? Now they're saying that how much you change this distance. Now of course you have to change so that the train is going to stop at the red. So how much distance should be kept between the yellow and red now? So you are in a two situation question. So you see that which data is given to you. So you look for the data. So you will say initial velocity is given, acceleration is given in a way that they're saying that acceleration is constant. And then the displacement is given, and then the final velocity is given because it is stopped. So you will see which quantity is missing. What is not mentioned? Time. Yes, you're right. Time is not mentioned at all. It means you will not use an equation which is involving time. You will use an equation that is not having time. So use an equation which is not having time. Okay, so that equation is 2as is v square minus u square. So you will use this equation and you will apply this on situation 1, sit 1, and you will apply this on situation 2, and you will simultaneously solve that. Oh, we run off the space, so what I have to do is I have to add a page into that. So let me add a page over there. So where were we? Yeah, we were here, I guess. Okay, so we got a new page. Okay, so let's apply this equation in both the situations. So in situation 1, 2as is v square minus u square. Be with me, this question is very challenging. If you understood this question, other question will be piece of cake for you people. Okay, so 2 and a is negative a and s is x in first situation, v is 0 and u is u. So you'll be saying it is minus 2ax equal minus u square. This negative negative cancel away. So 2ax is u square. You said, okay, this is my answer. It will not give you any value, but okay, this is the first situation. Now let's go to the second situation and apply 2as is v square minus u square. Okay, so 2 and a is minus a. S, we don't know s, we have to find. Okay, so this is s and v is 0 and u is 1.2 u whole square. This is important that the u is 1.2 u and you took the square of this. One common mistake what people do over here is they write 1.2 u square. This is wrong. Why this is wrong? Because you have to take the square of the initial velocity. So initial velocity is 1.2, that's why you're taking square of it. Now you simplify it, minus 2as is minus 1.44 u square. So minus minus goes away. So 2as is 1.44 u square. So this is your second equation. Now when you apply one equation twice, so you have to solve them simultaneously, or you can use the substitution method. What we can do is we can substitute the value. So let's substitute the value. Okay, so what we can do is we can substitute the u square value over there. So substituting u square value, it is 1.44 and the u square is 2ax. So now you can see that this 2 and a, so this is going to cancel away, 2 and a, so your left s is 1.44x. so this should be your new displacement. Your new displacement should be 1.44 times greater than x. So this here is your option. Well, this is MCQ, but yeah, this MCQ will build your concept. So you can always look at the solution again. You can go back to time to understand it again, and in case if anything comes up, you're most welcome to contact me. Okay, now let's jump to, we are moving towards the end, so we have to look for some more tricky questions which you can try yourself as well. So I can give you the hint and you can solve it yourself, and then you can post your answer in the comment box. Post answer in comments so that I can check that whether you have done it correctly or not. So this is, the heading is some tricky question number 1. You can post answer over there. The hint is that there's a deep well which is 78 meter below the 78 meter deep, and some person air resistance is negligible. It means G is 9.81, and the speed of sound in the air is 330. What is the time interval between person dropping the stone and hearing it hitting the sound? So look, actually the question is like, this is a deep well, right? And a person is standing over there, and that person is going to drop some stone or something in it. The stone will go and it will hit the water and it will make a splash sound, and that splash sound will get back to the person. So they're saying how much time after dropping the stone he can hear the sound. So this is a two situation. The first situation, you will see that how long the stone takes to reach from here to the bottom. So you have to find the time. So for that you have to pick the data. So the initial speed of the stone is 0, as air resistance is negligible, so G is plus 9.81 and the depth is 78 meter. You don't know about velocity, so you will use an equation in which v is not there. So you're using s is ut plus half at square. So you'll be using this to find the time. Okay, that's good. This is one time, but the total time is t1 plus t2. T1 is just the time to go down. T2 is the time that the sound takes. As the sound speed is constant, so you can do it like this: T is d by v. The distance is 78 and the speed of the sound they have mentioned is 330. So you will get this time and then you will simply add these two to get your total time. Okay, number two. Number two is again very simple. A boy throws a ball vertically upwards. It rises to maximum height where it is momentarily at rest and then falls back to the hand. Which row gives you information about the acceleration of free fall? So the situation is that the boy actually throws something upward. It is going upward at highest point, momentarily stops, and then it is getting backward. So what is the value? So I already told you that if the object is thrown upwards, the acceleration is always minus. Whether it is at highest point, it is minus 9.8. Whether it is coming down, it is minus 9.8. Because for G, the start point is important. If it is thrown upwards, G is always negative. So negative, negative, negative. So option B. Okay. This is the question that you will do yourself and you will post the answer. You can just write this and then you write the answer. A body having uniform acceleration A increases velocity from u to v in time t. Which expression would not give the correct value for its displacement? So if you look at the first one, it is s is ut plus half at square. So this will give you. Similarly, for you have to look for the other ones and you have to look for one which doesn't give you the value of displacement. You have to write the answer. The next question is again very simple. In an experiment to determine the acceleration of free fall, a ball bearing is held by electromagnet. When the current to the electromagnet is switched off, a clock starts and ball bearing falls. After falling a distance h, the ball bearing strikes a switch to stop the clock, which measures the time t of the fall. Which expression can be used to calculate the value of g? Remember, in free fall, whenever an object is dropped, you always have to use equation s is ut plus half at square, because this is also known as free fall equation. Remember this thing. This is free fall equation. You put the value s is h, initial speed is 0, 0 into t plus half, a is g and t square. So h is half gt square. And then you make g as the subject, so it is 2h over t square. So it is 2h over t square. Jumping towards the last MCQ. This MCQ you'll do yourself. A goods train passes, or I can just leave this for you so you can try it yourself and post the answer in comments. This is very important to follow all the directions. If you follow all the directions, it means you're going good work, and good work always pays you back in a good way. Okay, let's jump into some theory questions now. There are a couple of theory questions that we have to do. The first question is from the object M, which is on a slope, and there are some points R, P, and Q. which seem to be equidistant, and it's at P, its speed is 3.6. M moves up the slope, comes to rest at point Q. Okay, it means that final velocity here is 0, and then moves back down the slope to point R. M, it has a constant acceleration of 3 meter per second down the slope at all the times. Okay, so it means that its acceleration all the time downward is 3.0 meter per second square. At time 0, m is at point P and has a velocity of 3. So it means this is its initial velocity because the time is 0 over here. Total distance from P to Q and to R is 6. So P to Q and then back over here, the total distance is 6 meter. Calculate for the motion of m from P to Q, only from P to Q, only from P to Q, the time taken, how much time it takes. So P to Q, you know, at P the speed is 3 meter per second, and final at Q is 0, and then its acceleration all the time is 3 meter per second squared downwards. So as it is moving upwards, so obviously the acceleration is negative, because when it is moving upward it is slowing down. So you have three things and you have to find time. Obviously you will be using the first equation, or simple the acceleration equation, v minus u over a, sorry, and v is 0 and u is 3.6 and a is 3, so it will be oh yeah, a is minus 3, so it will be 1.2 seconds. So the time is 1.2 seconds. The distance travel, how much distance is from P to Q? Okay, it's not the same actually, P to Q. So you have to find the distance. So you use the same data as over there, and this time you have the value of time as well. So you can use any equation which is having s. So you can use s is u plus v over 2 into t. U is 3.6, v is 0, and time is 1.2. So it is 1.8 into 1.2. So 1.8 into 1.2 equals to 16. Cannot be 16 actually. So let me do it again. 1.8 into 1.2 equals to 2.16. Yeah, so it is 2.16 meter. Okay, show that the speed of m at r is 4.8. It means that when it is coming down and it reaches at r, I am just erasing it. So when it is coming down and it reaches at r, show that its final speed is 4.8 meter per second. So you have to start from the point Q, because at point Q it was at rest. So initial speed is 0, it is going down, and its acceleration is 3 meter per second square. This should be positive now. So we know that initial velocity is 0, and then its acceleration is 3 meter per second square, and we know the distance. Look, they told us the total distance as 6, right? The total distance is 6, but the distance from between P and Q is 2.16, right? So let's have a look at that. From P to Q and back to R, the total distance is 6 meter. But from P to Q, the distance is 2.16 meter. So 2.16, 2.16 and 2.16 back. So we say 6, we can say that the distance of PQR is equal to 2 times of distance PQ plus, or you can do one thing. We have to find the distance between Q and R. So we say just subtract 2.1 from 6. So it will be 3.9. Yeah, if I'm missing something. Oh yeah, it is 2.16. So 6 minus 2.16 will give you 6 minus 2.16 is 3.84. Yeah, so it is 3.84 meter. That is distance from Q to R. So 3.84 meter is the distance. That was the tricky part. And now you have to find the final speed. So as time is not there, so use an equation in which time is not there. So this is the equation. So 2 into 3 into 3.84, v square minus 0. So you just multiply them, and I can do it for you. So it is 23.4. So it is 23.04, and then you can simply take its square root to get the answer. 23.04, and you take the square root. It's not working, so it is actually v square, so you have to take the square root, so it's around 4 point something. Oh yeah, it's the same answer that we have to get. It is 4.8 meter per second, so that's how you have proved that. Okay, this question you can do it yourself. It's very easy. Just look at this question and then try to solve the question yourself. So try it yourself. So that's it for today. I hope this video lecture of 50 minutes helps you in better understanding towards the equation of motion. So in case if you find it difficult, you can watch it again, make your notes, and if you still feeling uncomfortable, then you can contact me. Take care until we meet again in a next video.